Hello Year 6 and welcome to today's science lesson. Today we are going to be learning all about natural batteries, and here are a few objects that we're going to be learning more about today. One of them is this lemon, another is an apple, and another is this battery here. You're probably wondering, what do apples and lemons and oranges have to do with batteries and electricity? Well, I was wondering the same thing before I learned that fruit, and especially citrus fruit, can be made into your very own natural batteries without using one of these. So we're going to learn how that works. So let me share my screen with you. Okay, natural batteries. We are going to learn how to make a lemon battery or an orange battery. So what I would like you to do is write in your books today's date, which is Monday, the 8th of February, 2021, and write down the question today. How could you use fruit to make batteries? Please pause this video now and write that down using a ruler to underline it if you can. Please pause this video now. Okay, once you've done that, can you please answer these questions in your book? I will read out the questions and we will go through the answers afterwards. Question 1. What is the name of the part of the bulb that produces light? What is the name of the part of the bulb that produces light? Pause this video now and write down your answer. Question 2. In order for a current to flow, the circuit needs to be what? In order for a current to flow, the circuit needs to be what? Pause this video now and write down your answer. Question 3. The greater the number of bulbs, the what? The brightness. The greater the number of bulbs, the what? The brightness. Pause this video now and write down your answer. And question 4, electrons move through a current, true or false? Pause this video now and write down your answer. Okay, let's go through the answers. Question 1, what is the name of the part of the bulb that produces light? That is the filament. Question 2, in order for a current to flow, the circuit needs to be closed. If you have an open current, the light bulb will not light up. Question 3, the greater the number of bulbs, the dimmer the brightness. Why? Because the more bulbs you have, the more current needs to be shared between a greater number of light bulbs, and therefore the light bulb will be dimmer. This is what we learned about last week. And question 4, electrons move through a current, true or false? This is true. Bonus point if you can tell me whether electrons have positive or negative charge. Think about it for a moment. Electrons have negative charge. Okay, now let's get on to today's new learning about natural batteries. If you have a piece of fruit, a couple of nails, and some wire, then you can generate enough electricity to turn on a light bulb. Isn't that incredible? So let's find out how this can be done. Before we do that, let's learn some key vocabulary. Please repeat after me. Citrus. Citrus. I've shown you some examples of citrus fruit. So lemons and oranges, generally sour fruit, is citrus because it's acidic. It contains acid. Okay, and that brings us on to our next word, which is acidic. When something is acidic, it has a pH value less than 7, so it tastes sour. In this picture here, we see some acidic fruit. Kiwis are acidic. Grapefruits are acidic. Oranges, limes, and lemons. Conductor. You know what a conductor is because we have learnt about this before. A conductor is a material that lets current pass through it. So metals are examples of conductors. And pH is a word that I just used. This refers to how acidic or alkaline a substance is. Water has a pH value of 7. If it's less than 7, it's an acid, and if it has a pH value of more than 7, it's an alkaline. So, because oranges and lemons are acidic, they have a pH value less than 7. Okay, what would we need to create our fruit battery? We need a citrus fruit, so a lemon, a lime, an orange, or a grapefruit. A citrus fruit is an acidic fruit. We need a copper nail or coin, or screw or wire. We also need a zinc nail or screw. And we need a multimeter or a small light bulb. So this here is a multimeter. Now, unless you have these crocodile clips, you won't be able to do this experiment, but that's absolutely fine. We're just going to learn about it in pictures and understand how and why it works. So this is a multimeter. It measures the current produced by a battery. It's particularly useful when the current is not strong enough to light up a bulb. So that is how we would measure the current that is produced by our natural batteries. The higher the number, the higher the current, and the brighter the light bulb would shine. Here's how to make the battery. We would insert the zinc and copper nails into the fruit so that they are about 5 centimeters apart. Don't let them touch each other. So here we see a zinc nail and a copper nail. There is the zinc and there's the copper in these different pieces of fruit. And out of these, can you please point to the 2 fruit that are the most acidic? Yes, it is the lime and the lemon. These are more acidic, so they have a lower pH value than the tomato and the banana. Okay, when the circuit is closed, the light will turn on. So this looks like a closed circuit. There is no gap. Or maybe it's actually probably, how do we know that this is not a closed circuit? Because the light bulb isn't shining, so there must be a gap somewhere. Now, why does it work? A lemon is a citrus fruit. We know that. The zinc metal reacts with the acid to produce electrons. The copper and zinc metals act as positive and negative battery terminals. So here we see copper and aluminium, or copper and zinc. This yellow oval represents a lemon, and that is our fruit battery. And because the zinc reacts with the acid, it produces electrons, and we have the current which flows. Isn't that amazing? Here's a bit more of an explanation. The wires of the small light bulb are electrical conductors. Well, we know that because we know metals are conductors. And when they're used to connect the copper and zinc, the electrons that have built upon the zinc flow into the wire. The lemon juice conducts the electricity, and that's why this light bulb shines. Okay, what I would like you to do is please draw and label a diagram and explain how and why this works. So I have modeled this for you to show you what it should look like. Okay. Now let me show you here. Well, we should have already written today's date, which is Monday, the 8th of February, 2021, and then written out today's question, which is, how can we use fruit to make batteries? And then the question, which is question 1, is, how does it work? Now, using a ruler to underline it all, to keep our presentation neat as we would in school. And then I would like you to draw the diagram. So, starting off with the shining light bulb, using a ruler to draw the wire. Now, these two nails here represent the copper and the zinc nails. That is my lemon, my acidic citrus fruit. So I've labeled it here, fruit acid, because inside the lemon is acid. And I've labeled it here as my lemon, and there's my actual lemon. If you want, you can use, if you have yellow coloring pencils or yellow highlighter, you can color that yellow. And I'm labeling that as my fruit battery. Now, that is my copper nail. That's inside this lemon, and that is my zinc nail. Now, the next thing I need to label is the direction of the flow of the current. So I'm going to label that as current flow, because we know that the zinc reacts with the acid, and that's what creates the flow of electrons. And there I'm just showing you what a man-made battery looks like. But what we're dealing with here is a fruit battery. So once you have drawn the diagram and labeled it, I need you to write a paragraph about how does it work. So a lemon is a citrus fruit. I know that. The zinc metal reacts with the acid. React is an important word. There's a chemical reaction. Reacts with the acid to produce electrons. Make sure you use the word acid. You don't have to write exactly what I've written. You can put it in your own words. The copper and zinc nails act as positive and negative battery terminals. So that is explaining how it works. And we've labeled everything in the diagram here. We've got the zinc and the copper, and they act as positive and negative battery terminals. And here, just to show you, that is the positive and negative terminals of a man-made battery. Pause this video now and please write down your own answer to this question. How does it work? And draw your labeled diagram. I can't wait to see it on Seesaw. Okay, now my question for you is, which fruit makes the best battery and why? Let's look at some different fruits that we could possibly use. At the beginning, I showed you an apple. We could use strawberries, tomatoes, peppers, apples, watermelons, and squash. We see eggplant, pineapples. Now, one thing we know is that all of these different fruits have different acidity values, have different pH values. Some are more acidic than others. I can tell you now that some of the most acidic fruit here are lemons, because they're generally the more sour fruit is, the more acidic it is. So lemon will be acidic, and orange will be acidic. Can you spot any other fruit that you think might also be acidic? So now I'm going to model for you how best to answer this question. Okay. Right, I have modeled it in this video here. Which citrus fruit makes the best battery and why? Please underline it using a ruler. Okay, citrus fruits have acidic content. We know that. We know that citrus fruits have acidic content, and the more acidic it is, the better it is for conducting electricity. the more acid there is, the better it is at conducting electricity. So, thinking about which fruits have more acid in them, do you think that a lemon or a lime will make a better battery than, say, a banana, which has less acid in it? So I would write, so a lemon or lime would be better than a banana or apple. Why? Because they have more acid in them. So they have a pH value of less than 7. Okay, great. So please pause this video now and write down your answer for which fruit makes the best battery and why. Okay, and here is the answer. Citrus fruits have an acidic content, and the more acidic it is, the better it is for conducting electricity. Now, my final question for you is, what would be the effect? What would the effect be when multiple fruits are added into the circuit? So not just one lemon or lime, but 4. I've got 3 lemons here. What would happen if I put 3 or 4 of them in a circuit compared to 1? Please pause this video now and think about your answer. Well, I have modeled it for you here. The question was, which fruit, or what would be the effect when multiple fruits are added to the circuit? What do we do with our titles? We always underline them. So, the more fruits that are added, the greater the acidic content. Therefore, comma, the current would be stronger and the light would shine brighter. So the more fruit we add, the brighter the light would shine. Please pause this video now and write down your own answer to this question. Well, Year 6, I hope you've enjoyed today's science lesson, and I can't wait to see your diagrams and answers on Seesaw. You will make some great scientists. Bye, Year 6.